discussed 1, 1 and onto function. And regarding to that, we have started our exercise 1.2 also. Now we continue with 1.2. Yesterday we have completed second question of 1.2 exercise. So today we start with third question. What is your third question? You open your book and read your question. Third question is, prove that the greatest integer function f r to r given by fx equal to integral x. Fx equal to integral x is given and you have to show it is neither 1 1 nor onto, where integral x denotes the greatest integer less than or equal to x. First of all, let's revise what is integral x. We have already discussed type of functions in our 11 classes. First, integral x. Two ways we learn. One is ceiling function. What is it? Ceiling function. And second is floor function. Floor means we are writing lower value and ceiling means we are writing upper value. So that way we have discussed two integral functions. Now here integral function is given but less than or equal to term is mentioned. So suppose I consider x between 1 and 2. So we have to consider at that time 1. If your x between 2 and 3, that time you have to consider 2. But if your value between 1.2, suppose we are writing integral 1.2, then also we have to consider 1. 1.3, then also we have to consider 1. 1.5, then also we have to consider 1. So what is the meaning of it? For different question, you are getting the same answer. So first part proof, it is not 1 1. Okay, now we have to check range and codomain. So your function suppose mentioned from R to R, then what is it? You have to consider all the real numbers. So if we consider suppose minus 1.2, then also otherwise let's take plus 1.2, then you get 1. 1.3, then also you get 1. Suppose 5.4, then you get 5. Means what do we get? We are not getting the rational numbers. We are getting all the perfect numbers, means integers. We get 0 also, we get minus numbers also. So what is the meaning of it? This codomain and range both are not same. If so, then this function is not 1 1, not onto. Now I think way of writing is very much clear to you. So now come to the fourth question. What is our fourth question? Check it. Fourth question is, so that the modulus function f r to r given by fx equal to integral x is neither, not integral x, modulus x is neither 1 1 nor onto, where modulus x is x for positive or a 0 and modulus x is minus x for negative. Let's first mention this modulus function. Fx equal to modulus x. It's equal to x if x is more than or equal to 0 and equal to minus x for x is less than 0. These two ways it is mentioned. But you know very well that in modulus minus 2 became plus 2 and plus 2 also plus 2. So for many question, one answer. So function is not 1 1, many 1. Now when you write a range of it, range must be all positive numbers or 0, because when modulus we are writing negative numbers became positive because of modulus. So we get range as a R plus, means all positive numbers and 0 only. So which is not equal to set of real numbers. So not onto. So both one is clear that it is not a 1 1 and not onto. Now your next question. This is your question number 4. Now your fifth question also same. Check fifth question with signum function given. What is the signum function? We already learned signum function fx equal to x. See which example we learned? This one. So for x is more than 0, what do you get? 1. For x equal to 0, you get 0. And for x is less than 1, you get minus 1. So this way we already learned it. Now we have discussed this question. If you consider this only, so modulus for 1 more than 1 equal to 0 and less than 1, then also you can get in that format answer. So let's check that signum function is a 1 1 and onto or not. Read your question. So that signum function f r to r given by 1 if x is more than 0, equal to 0 if x is 0, and equal to minus 1 when x is less than 1. Maybe printing mistake is there, you can check it. Neither 1 1 nor onto. From the first look only you can understand that if we consider this signum function mod x upon x, any number you consider x equal to 1 or 2 or 3, you get one answer only. So what is it? Suppose I consider 2, then 2 upon 2 will be 1. If I consider 3, then 3 upon 3 also 1. If I consider 1, then 1 upon 1 also 1. So for many questions I get the same answer. And range and codomain, when you check range and codomain, your range is only 3 answer. What is the range? Minus 1, 0 and 1. So which is not equal to r. R means set of real number. So from these 3 questions we have derived that signum function, then integral function may be greater or given or least number or lowest number given. Then for 3 terms, for modulus function, modulus, then signum, and third integral. For all 3, function is not 1 1 and onto. So that one our 3 questions in which we have to prove that the function is neither 1 1 nor onto. Now come to the 6th question. In 6th question what is given? Mentioned A as a 1 2 3. Then B is given 4 5 6 7. Now relation is mentioned by 1 4 2 5 3 6. Be a function 3 6. Be a functions from A to B, so that it is 1 1. Okay, let's start with Venn diagram A and B. Now we are mentioning this by a function. In A we have 1 2 3. And in B we have 4, 5, 6 and 7. But the relation is given A with 4. Matlab first 1 with 4, 2 with 5 and 3 with 6. So check. For one question, one answer. One question, one. So this relation is 1 1. Now only this question that check it is 1 1 or not. So our answer is true. But if I want to ask for the same question, it is onto or not, then how can we check it? First we have to write the range of this function. What is the range? 4, 5 and 6 only we are getting as an answer. Right? Which is not equal to 4, 5, 6 and 7. So what is the meaning of it? Range and codomain is not same. If so, then this is not onto. But in your textbook only one question is asked, that is you have to check is it 1 1 or not. So it is 1 1 we have proved, and you can consider with the same Cartesian coordinates only, that with 1 only 4, with 2 5 and with 3 6, single question single answer means function is 1 1. If one question more is added, that check onto also, then you can say it is not onto. Just for your understanding I have shown it. Otherwise you have to write for 1 1 only. Check next question, 7th one. What is our 7th question? Function is mentioned from R to R. In 7th 2 questions are there. First is fx equal to 3 minus 4x. And second question is fx equal to 1 plus x square. You have to check is it bijective or not. Bijective means it is 1 1 and onto. Both one you have to check. So let's come to the first question. Let's start with it. We will prove it by definition only. Let's take f of x1 equal to f of x2. Means 3 minus 4x1 equal to 3 minus 4x2. So from both sides let's cancel 3 3. So minus 4x1 equal to minus 4x2. From both sides, let's remove minus 4. So x1 equal to x2. So from this we can say it is 1, 1. Now let's take this as a y equal to 3 minus 4x. So we can take 4x equal to 3 minus y and x equal to 3 minus y by 4. Now let's put up in 3 minus 4x. So 3 minus 4 into 3 minus y by 4. 4 cancel. 3 minus y minus minus plus 1. So sorry. Minus plus cancel. Now what is the remaining part? Y. So from this you can say it is onto also. This is by the definition. Now let's prove by our example. Let's take first real number. Let's take minus 2. So minus 2 minus 4 plus 8 and 3 11 minus 1 minus minus plus 5 and 3 8 0 then 3 then 1 then what you get 4 ones are 4 and I must subtract from 3 minus 1. So single question, single answer and you check all real numbers you are getting. So it is 1 1 and on 2. So first part here I have shown both things by definition and then with example also we have discussed. Now let's come to the second question. What is our second question? See, fx equal to 1 plus x square. Now from the question only you can understand that x square is there, right? So when you write square of any number, minus plus both became plus. Let's start with minus 2. If we take minus 2, 1 plus minus 2 square, 1 plus 4, so you get 5. Let's take second 2 only, 1 plus 2 square, again 1 plus 4 is 5. So for two different questions, same answer. So not 1 1. First part from example we have taken. Now the same way, when you find the range of function, you get only all positive numbers. And which numbers? More than 1. Because here suppose lowest number you consider 0. Then square of 0 is 0 or plus 1. So number must be more than 1, not a negative number. So which is not equal to r. So not on 2. So this one we have shown by example. Now let's prove by definition. So we can understand how to write it. Let's start. F of x1 equal to f of x2. 1 plus x1 square equal to 1 plus x2 square. 1 1 cancel. x1 square equal to x2 square. So we can write plus or minus x1 equal to plus or minus x2. So 4 relation you will get. x1 x2 say x1 and minus x2 minus x1 and x2 and minus x1 minus x2. So we cannot say here it is not 1 1. Okay, now range and codomain, that also we have checked, and by the definition if we take 1 plus x square, then 1 minus y equal to x square. So when you take group with plus or minus we have to write, so that is also not on 2. So this one I have shown by definition, and in the beginning we have discussed by the examples also. Now I think 1 1 and on 2 how to write and how to understand, it's more clear to you. Now let's come to the 8th question. What is your 8th question? A and B are two sets and your relation is mentioned f A cross B to B cross A such that f of A comma B equal to B comma A is a bijective function. Bijective means what? We have to prove 1 1 also and on 2 also. Okay, let's start with f of a1 comma b1 equal to f of a2 comma b2. So from this you can write b1 a1 equal to b2 a2. So what is the meaning of it? b1 and b2 is same, a1 and a2 is same. What is the meaning of it? a1 b1 equal to a2 b2. So from this we can say it is 1 1. First part true. Now let's come to the second part. We have to take for onto. What is the thing for onto we can take? First, let's take one element B comma A. What is given your term? B cross A. This one. So in B cross A. What is the meaning of it? B in B and A in A. We are doing for on 2 because for 1 1 I have already solved. Okay. Now what is the meaning of it? That B comma A is arbitrary element of B cross A. What is the meaning of it? We can write A comma B equal to B comma A. That means you can say it is on 2. Okay, for 1 1 what we have done? That we have taken f of a1 comma b1 equal to f of a2 comma b2. And we have taken b1 a1 equal to b2 a2. Now what we can write? b1 equal to b2 and a1 equal to a2. So we can say a1 b1 equal to a2 b2. Therefore you can say it is 1 1. So from this it is 1 1. From this we have proved it is on 2. Therefore this function is bijective. 1 1 and on 2 both. Just check it once how to write the method. Then we can start our 9th question. I think this one is more clear to you. 1 1 and on 2 by definition we have written. Okay, come to the 9th question. Let f and 2n, matlab set of natural number is given, and it is mentioned that f of n equal to n plus 1 by 2 when n is odd, and equal to n by 2 when n is even. Now you have to show that is it a 1 1 or on 2 or not, and you have to give your justification for it. Okay, let's first start with natural number f and 2n given. Means we start with natural number, and our first natural number is 1, and you already know 1 is an odd number. So we have to choose this function. So what is it? 1 plus 1 by 2. That means 2 by 2 you get 1. Okay, let's take second natural number 2. 2 is an even number. So 2 by 2 it's again 1. So for 2 different questions you get the same answer. So not 1 1. First thing clear? Now let's find out the range of it. So for that let's start with third natural number. 3 is a odd number. 3 plus 1 by 2 means 4 by 2. So you get 2. Now let's take 4. So 4 by 2, n by 2 because even number, so 2. So what is the meaning of it? You get all the numbers. But when you take n plus 1 by 2 and n by 2. So up till all that numbers, what you get? Range and natural number only we start. So here range and codomain is same. But it is not on 2 because we are getting the same answer for 2 different questions. So this one clear to you, and how to write with the definition you already know it. That f of n1 equal to, you have to start with f of n2 and you have to end with n1 equal to n2. But here n1 and n2 will not equal as I have shown by the example. If you don't get the definition proper way, then also by example also you can prove it. So we continue with our next question, 10th one. What is your 10th question? Here in 10th one, function is mentioned x minus 2 upon x minus 3, and a is given r minus 3 and b is given r minus 1. You have to check is it 1 1 or not. So what to do? First we have to start with f of x1 equal to f of x2. So x1 minus 2 upon x1 minus 3 equal to x2 minus 2 upon x2 minus 3. And then you have to show 1 1 and on for 1 1 what you have to show x1 and x2 same. That we can do. Now how can we take a cross multiplication and then you arrange in such a way that you can prove for separately x1 and x2. So okay, we just now we stop because we have lack of time. So we continue the same question in our next class. So thank you.